Ryan with Miss Dog Geek here, and in this video we're going to take a look at a couple of features that I want to add to the BITX40 and talk about the next steps. So one of the first things that I wanted to add to this, since I've got it calibrated and I know which BFO frequencies are needed for upper and lower sideband with high side injection, I wanted to do the same for low side injection, which I've done. I modified the script on the Arduino so that it uses low side injection. Now the difference is this. High side injection means you take the IF frequency and you add the 7 megahertz or whatever it is, whatever frequency you want, you add that to the IF frequency and you end up at around 18 megahertz. And so you inject 18 megahertz through the local oscillator and you inject the 11 or so megahertz into the IF, and that goes through the crystal filter, and it comes out as either upper or lower sideband based on which side of the crystal filter you're using, which skirt you're cutting out your sideband off with. So that gives you basically you use either side of the crystal filter to get your sideband. Now, there's also a thing called low side injection, where you do the opposite. You subtract your desired frequency from the IF. So, if it's 11 megahertz IF minus about 7.1 megahertz, you end up at 3.9 megahertz. So that's called low side. In other words, it's below the IF. And the effect of it is that you end up using the opposite sides of the filter to get lower and upper sideband. So I forget which side of the filter is used for each, but if you want upper sideband on high side injection, then let's say I'm just pretending here because I'm not sure which it is, but you're going to be using the lower side of the crystal filter. But if you switch to low side injection, the crystal filter switches too. And because the crystal filter has different shaped skirts, where it has its filtering, they sound different. So I would like to add that so you can switch from high side to low side injection just to basically move the filter around a little bit. And then I'd also like to have for receive only, so I'll have to sense transmit so that I don't do it on transmit. I want to copy a feature that my Kenwood has, which is IF shift. I'm not sure how far it shifts. I'll probably look up the documentation, but I'm thinking maybe 50 or 100 hertz either direction. And what I'll do is I'll use a potentiometer on one of the analog pins, and then basically make it part of a voltage divider, just just kind of like the original Arduino did, so that when it's centered, the IF shift is neutral, but when I turn it left, the IF shift goes down and reduces the IF and frequency and vice versa. And I'll probably indicate that on this giant screen here so that I know where the IF currently is. That way I can zero it out. So anyway, that's what our goal is, or that's what the long-term goal is. The short-term goal today, and the point of this video, is going to be adding a bandpass filter and getting the first stage of the PA hooked up so that we can actually get a little bit of amplification and maybe hear sideband coming into the Kenwood by transmitting into a dummy load. So that's the goal, and I'm going to go ahead and get started on it, and I will bring you along for the ride. So right now I actually have the PA driver configured, and it's actually going out to my antenna just because it's a couple of milliwatts, but interestingly it is working. I'm actually modulating sideband. In fact, I had to turn down the volume on my Kenwood or else I got feedback, which is indicating that there's a pretty good amount of audio. So the thing is actually working. I'll show you the setup that I have in the circuit now, and then I'll show you what we're going to do to get the PA going. Alright, so as you saw in the previous segment, it transmits. Now, it's only transmitting maybe a few milliwatts, but The PA driver right here is not terminated. It's probably running at whatever, 200 ohms or something. So I can't measure it with my RF probe because my measurements are supposed to be at 50 ohm. I've got a jumper going from that driver all the way to the relay, and then that goes out the antenna connector, just as the original PA would have done. The main difference is that that's not exactly what I'm doing. What I'm going to be doing is I'm going to be hijacking this connection right here for the PA. And the PA is going to be the QRP Labs IRF 510 push-pull 10-watt board. Great little board. I mean, I don't even know why you would engineer your own when this board exists. It's $25 for this and for the giant heatsink and all the hardware. It's kind of a no-brainer in my opinion. Same thing with the QRP Labs filters. It's just a no-brainer. They're already done. All I have to do is assemble them. I did have to restore a 0.01 microfarad capacitor that I had removed. I think it actually broke, and because of my previous modifications. And one of the legs on this, I think that's a 2N2222 or a 2N3904. Anyway, just an NPN transistor. One of the legs on that wasn't even touching. My previous magnifier was terrible, so this new magnifier is actually really good and helped me see what I had done wrong, and I got that. And I could prove, as you saw in the previous video, that the RF is actually getting out to the antenna, and it is being amplified by this guy. So I couldn't measure it because this isn't 50 ohm. In fact, when I grounded out my antenna wire, antenna cable, it went from random impedance to 50 ohms, and that stopped it dead in its tracks. So it's not terminated properly. It was previously. It went to a 4-to-1 transformer, but it doesn't now. And the QRP Labs PA doesn't require a specific impedance input, so this will work fine. At least I'm really hoping it will. At least I believe it will. So thanks for watching, and I'll be posting more as I have it. Hopefully this coming week I can get some more content for you, and hopefully get this bad boy on the air. I am really excited to see this thing get back on the air and making contacts with sideband, with lower sideband voice, with upper sideband, with digital, and just get it back on the air. It's really important to me that this thing lives again. And then I got to figure out what to put it in. Once I get it going, I got to figure out what I'm going to do for a case. So anyway, thank you for watching, and if this is your thing, make sure you subscribe, click like. Clicking like actually really helps me because it makes YouTube tell other people about it. It's kind of how their algorithm works, at least I think. So I would appreciate it. So thanks for the watch, and 73, we'll see you next time.